Well, Tony, it's about time to start this lunch and learn session, September the 11th, 2023. Before we really get into it, I'd like to mention, and I'm sure everybody knows that 22 years ago today, 9/11 was when the Twin Towers were attacked, and we lost almost 3,000 people on that day, and we've lost several thousand more since then from the pollution that was caused by that, and then by the two wars that have taken place since then. For anybody that's listening, we want you to know that, and our heart goes out to you. Thank you for what you have done for our country. Tony, it is September the 11th, and this is another session of Lunch and Learn. Welcome again, sir.
Well, thank you.
We're going to be jumping in today to Flex Duct. Now, we talked about this in January of 23, almost a year and a half ago. But you sent me some pictures the other day about some Flex Duct installations, and I think what it proves is that we still have a lot to learn. We need to begin by saying that everything that's in here in this presentation today came from the Air Diffusion Council. It also came from SMACNA and from Manual D and ACA and the International Mechanical Code. So we've done quite a bit of research to make sure that what we're putting out is in fact the truth. First off, I want to mention, in fact, Tony, you brought this document to me and to our state a couple of years ago, I guess it was. Talk a little bit about this.
Okay, so this is an actual how-to pamphlet from the Air Diffusion Council, the Flex Duct industry themselves, on the proper installation methods of how you install their product, what's required by their product to be installed properly to get the proper airflow. And I'd like to add to that for those that don't have a ductilator from the Air Diffusion Council, which all of the state do, those numbers, when we come in and we tell someone you're undersized, that's from them. That's from them saying, this is the air you're going to achieve out of this size flex if properly installed. So when we get out there and guys are going, you've got a 6 where you would add a 6-inch pipe and it's bent all to pieces, you're not achieving what they're after. So we're just showing to light their information. This is not the state going, this is the minimum that we're trying to get you to meet to.
And Flex Duct has had a difficult reputation over the years, and people can like it, people can dislike it, but one thing's for certain, we ought to at least follow the standard that the manufacturer says we ought to follow when we're putting in their product. First off, we'll go to 4.3, which has to do with that we don't need to just string it out everywhere.
Correct. Right.
Have you ever been in one of those attics where it looked like somebody took the box of Flex and threw it across, and wherever it landed is where they put in a grill, and whatever was left, they just.
We don't have enough time for lunch and learns for all those pictures. We got plenty.
Here's a picture from the Air Duct Council that says, "Hey, this is the right way to do it. Come on."
Right. That is a correct way to do it. If you can softly turn that amount. And what they're calling softly is a 4% deflection, so if you want to visualize that, that's a 1/2-inch bend. And what I try to get, if you were to try to draw a straight line and that flex is going underneath that straight line, when they do this radius turn, there's less than a 1/2-inch bend there, even though that full volume is turning without a mechanical 90-degree elbow. And that's where they're going, okay, on your drop-in ceilings, this is how. If you have your trunk line or branch runs and you can do a small drop, do it like this. If not, you can go and then use a 90-degree elbow up there closer to that to avoid that, to keep that restriction from happening.
Well, here's the picture that they say is not correct.
And we see that daily. We see that all the time. And
the thing that I thought was so funny in their instructions is that they said, don't put extra flex in there just in case you wanted to add another drop sometime. I'm thinking, people are not worried about adding an extra drop. They're just worried about throwing that stuff in there and not having to cut it and do like the other picture. Anyway, that's my aside on that.
Yes, sir.
Here's where we're talking about the bend that we're showing there, and it says that the bend or that radius should be no less than the diameter of the duct itself.
Right. They're trying to keep that volume, that full flow. So, and then you take a 12-inch flex, then you're going to have that bigger diameter to make that turn. And that's, the flex duct is what it is. It's a quick it's a quick product, and that's part of the problem. It is speeding things up, but you know, I will say there's several contractors that do a great job with Flex Duct. Some of our newer contractors are getting involved with this, and they're not quite reading all the, you know, I've had several that said, I'm not even aware of that ADC council. But what I will tell any new contractor in this industry, in that Flex Duct box is a quick sheet. It's a pictorial sheet. When you get to the bottom, you pull that out. It's in there, and it's these pictures right here that you're looking at. Yes, sir. They're in the Flex Duct box. Where does it go? It goes in the trash.
What are you going to say? But then we'd need to read it.
Well, we got pictures.
Okay. This talks about these requirements came from ACA Manual D and ACA Manual Q, and that's referenced with the Air Duct Council there. Yep. All right. Here, let me back up just a little bit. It just says that the installed ducts should extend to their fullest length without compression, without it being accordion-like there, which is what you were talking about a while ago. And this is the picture that they include to try to demonstrate that.
And that's pulled way out there. In this demonstration here, you will actually see this on the ductulator we use. That actual is there, saying a 10-foot duct by the time we pulled it 9 foot 6 inches. I mean, when we pull that properly and don't bunch all that up, those U-bends going all the way through there, they need them taut so that the air won't do more eddy currents inside of the Flex Duct system. That's a good one.
To me, this is just amazing. And that is that if you don't stretch it out to that, say 96% of the extended length, if you only got a 15% restriction there or compression, I mean, that's not very much, but yet the friction rate is doubled. That's crazy. That's amazing.
It is crazy. And we show on the ductulator, we show them, look, this is what you've done.
Yeah.
This was the load you handed us and your calculations. Here's what you've done now. You're not meeting what you designed it for. So correct. That's a good one.
This next picture, the reason I put this in here is, you know, hey, it's Flex Duct, it stretches out, it's smooth inside, we think in terms of, but because it's got all of those ridges, can you imagine driving across this?
That's a good point. Yeah.
And that's what we're asking our air to do, is to drive across down a piece of Flex Duct, and the inside of it looks like this.
Yeah. That's good. It's a up, down, beat around, isn't it?
You ever kind of drift over a little bit in your lane and run over to those little bumps that are supposed to wake you up?
Oh yeah.
You know, kind of look like this.
That's right.
Well, again, the same thing. Everybody drifts out of their lane every once in a while, and we automatically know we've done a wrong thing. Well, you know, with Flex Duct, we don't need to drift out of our lane. We need to pull that thing tight. We need to stay in our lane. Anyway, I just thought it was funny. All right. In terms of support.
Yeah. So the metal versus the mesh webbing for hanging this product. So if you get to the ADC Council and then get with SMACNA duct design construction standards, you have to have a real wide piece of metal, 2.5 inch, if you're going to just do the metal, or if you want to do a metal saddle, then use metal strapping, or you can just use the mesh webbing itself and wrap it around, pull it up, tighten it like that every 4 feet. I don't know if the next slide has that. Yeah, 4 foot. That changed from 5 feet to 4 feet. And then they're talking about the sag there with your 1/2 inch sag.
Yeah.
Is what
Here's a little picture right here to demonstrate that.
Yes. Yeah, that's and you know, I would say this gets past, you see this, but then it's our 2-story houses where we're seeing the majority of, they just, you know, and they're going, well, what am I supposed to do? They're not giving me ample room. And again, this is where we got to get with the builders to, hey, you know, help the heat and air guys out. You want to treat this, but you're wanting them to go and then immediately do a 90-degree turn with a Flex Duct. It's hard to cut that, put an elbow in there, and then go from there. So that's where we're seeing a majority of it. Townhouses, multifamily dwelling, 2-story. It's tough.
Well, you said something I think is very important, and that is they're not giving us, as though they're giving us a gift. It's not a gift. It's a code.
Yeah. Right. We're handcuffed by our code as they're All right, it's like a builder that gets wrote up for not putting anchor bolts in the building. You stretch out more than your every turn 1 foot, and then you go every 4. They're same, so because we're bound by code as well. So yeah, it's a good point. That's what we see right there. Yeah.
Hey, this is the picture you sent me.
There you go. And that's a good picture for not only is not improperly run, that's not even proper flex duct anymore. So for any distributor or anybody watching this, distributors as well, if this shows up at your warehouse, if it's vinyl back, send it back. Vinyl back's not allowed in the state of Arkansas. So it will not meet the perm. So you can just send that back to your distributor or your vendor and go, send us the wrong stuff. We need the foil back.
Well, and it's not just Arkansas. It's ICC, it's IMC, it's Air Duct Council. Right. You didn't wake up one day and try to figure out how you could make life miserable for people.
That first slide you showed with ANSI standards on there and everything, that's it all back to that, correct?
Yeah. Here's one. It's a little hard to see here, so let's blow it up.
It's turned, it's pulled taut, it's going, besides being the improper flex duct, he did pull that one tight. I give him credit for that. It was pulled tight.
Well, it's only compressed a little bit when it goes across that rafter, when it comes out of the plenum and goes across the top. And of course, I'm being sarcastic. I'm sorry. No, I'm not.
Are you trying to build a static regain there, Tom?
Yeah. We're about to look at that. When people are talking to you about not compressing it, you know, what are we really talking about? Well, it shows the equivalent lengths of just a turn in the ductwork. And then it shows the equivalent lengths of just 2 turns in the ductwork. That this little old thing right here, which is only about maybe 6 feet total, it's just like trying to blow air through 50 feet of pipe.
And even if we were metal, we're looking at probably 12 to 14 foot of equivalent, because we have that same process, just not as much with the ringed. I don't know what I always call it flex part. I don't know what it's actually called.
Here's one of the things a picture that they have in the ADC there, which is so good because it looks like it's only 12 feet from the plenum over to the boot. And yet you add up all the various things that are going on there. You got 35 equivalent length coming out of the plenum. You got about a 2 foot measured length, a 10 foot 45 degree, another 10 foot 45 degree. You got about 12 feet. You got a 20 foot equivalent length on the last elbow down here. And then you've got 35 on your foot in here. So this little old 12 feet really is like trying to push air down a 124 foot piece of pipe. So now we see why we're putting so much stress on our blower motors and fans.
Right. And then we come to these smart blowers.
And you know, that's a good issue. I think the common misunderstanding is that if you've got one of those smart blowers, that sucker will just ramp up and give you what you need no matter what you need. But there's a kind of a fallacy in that, isn't there? There
is. And okay, so the issue with the smart blower is the efficiency, but what are you doing to the efficiency now? You're making that smart blower have to work harder than it was really designed to work to begin with. It is a smart blower, smart motor, and it has to run at a certain speed so it doesn't overheat and to feel the static pressure we've designed. But it's not thought into this. And then we do get in attics and go, well, that room all the way over there with that 38 foot run of flex never gets air out of it. That's the one that never gets there. Well, that's a prime example right there.
And this I thought was interesting, where it was talking, if you were making a correct turn, that it had to be supported on both sides of the turn.
That's part of it, right? If it's straight and laying flat horizontal so it doesn't dip down and turn inside, and that's per ADC council themselves as well. If you're going to try to not, if that's not resting on rafters or resting on a solid support foundation, a flat area, that's correct.
Oh, here's where it was talking about the support, like you were talking about a while ago. And it was saying that the metal has to be at least 1.5 inches.
At least 1 inch. Yes, it does. It's got to be a wide metal. And we've even run into issues where we'll cut that You got to be careful with that on the metal side of that, making a proper snap.
Sometimes what ADC or the code will let us get by with, to me, is not enough. If I were doing this, I wouldn't be happy with 1.5 inches. I just don't feel like it's got enough support there, like you were talking about a little earlier. But I don't know, depending upon your local inspector, I guess they could reference the ADC and say, well, it'll work at 1.5 inches, but I just don't see how.
Yeah.
This is interesting as well. If you're coming off your plenum, not off your plenum, but off your trunk, you come out with a piece of metal.
So, and what they're showing there is the old dovetail when they cut them in.
Yeah.
It's not the secured airtight, because you weaken that, and then so yeah, they're showing that. Which
they didn't want it sagging off of that metal and wind up cutting it, because there's going to be some. It doesn't sound like it, but there's going to be some vibration because of the air moving through there. So it's a constant, like a saw effect.
Yes.
Okay. What you mentioned, laying it on top of ceiling joist.
Yeah. And then we get answered questions like, well, they blow insulation. Yeah, they do. They blow cellulose, they blow fiberglass in there on that. And very rarely I have seen some heavy cellulose put in spaces, but it also looked to me like the flex duct got stepped on. Now, it might have been the insulator himself at the same time, but it looked like it was completely compressed down, stepped on. But yeah, can this be covered in insulation? It can. There was arguments with that back and forth, but I don't know the insulation itself is going to compress the flex duct. If the flex duct pulled pretty taut, it should be okay.
This is what I mentioned a while ago. I got ahead of myself on that flex duct riser where it's got to be supported every 6 feet.
Yes, and I want to really caution anybody about flex duct risers. You better really consider metal pipe in a flex duct riser going from one floor to another, because anywhere you penetrate the wall, the ceiling, the sidewall, so it's really hard, unless this is going to be visible all the time, it's really hard to a flex duct to be allowed to be run in a vertical, because 6037 is going to tell you're going to go into that wall, then come and go back out above ceiling. That's all hard pipe. Then you can transition back to your flex duct. So be very careful with this.
Even so, it says you're only limited, or you are limited to 2 adjacent floors.
That's
you can't
correct.
Go to the 3rd floor.
Right. That's right.
Here's you remember back, Tony, in 2015, we got into such a bunch of head scratching and fussing about how do you join flex together? How do you splice it? How do you put it on your takeoff coming off of your trunk? And the Air Duct Council here has a lot of really good information in it that people ought to consult.
And again, it's step by step how you shall do it. I'm hoping most folks can, when it comes 25 foot in a box, I'm hoping most folks can make a branch run to the diffuser. Less than that, but in some cases it has to be extended.
Well, one of the things that we used to scratch our heads over was the question about, okay, when you're going to use a connection or you're going to use a splice, how in the world do you secure that to make it work? And here the council talks about using a transition piece and putting the core on there, and then wrapping it with tape, and then using clamps. Now, used to, we were also talking about using screws, and I remember everybody said that doesn't make any sense.
Yeah, and the screws would have the vibration; it would pull away from that, and it cause a problem. And those true, what I call the old thermostatic, your old pipe that come off your radiator, them little true pipe clamps. You don't see those; they use the zip ties.
Yeah.
They don't use that. They'll zip tie that down. But that picture's a good point, because if you don't do a duct leak test, duct leakage test, then your inspector he could ask to see a physical mastic of this, where this goes, because he can see the end joint, but where you're going there, he could ask to see, unless you decide, okay, we're going to give you the duct leakage test, and then go that route, which that board did say, okay, we'll accept the duct leakage test over a visual inspection.
This next picture is kind of earlier we were talking there about mainly splicing. Here we're talking about, connecting to your trunk line. And here they suggest that you might want to start by putting mastic on the metal and then pulling the core over it and then taping it and then putting a clamp. And then
I've seen this done in Texas. I really have. I witnessed them do this. They would do the mastic, pull it, zap it down, mastic back over it, and pull it in. They were in several housing districts down in Texas. They were doing that. Of course, they do a lot of duct board down there as well.
Mm-hmm. Well, I'm an old mastic guy, so anytime somebody has a brush with mastic on it, I feel like they're doing a fine job.
Yeah.
Tony, all this we've been talking about is available for free online.
Sure is. You can print that. You put it on your phone, put whatever, and it's that 14-page or whatever. You just download that. It's that how-to guide. It is free, absolutely free.
Depending upon how you go in, if you sign up for this class, which is free, they will give you the book.
Right.
If you don't sign up for the class, and again, depending upon how you go in, I think yesterday I lost mine, and so I signed up and I paid $15, which I was very happy to pay. But then I got to searching a little farther, and I made sure I was actually on the Air Duct Council site, and it was a free class. And if I did that, I also got the free book. So this information is readily available. The cool thing about it is, as you said, it's downloadable to your computer, so you can look at it anytime you want to.
You can. So I had two questions. One asked, what about mobile home crossover under house vinyl? Okay, so that is done by a third-party inspection. So the duct system and then that crossing down that's part of the system that's considered third party. Our jurisdiction in the state is over the pad, the line set, the disconnect, going up and then drain line, getting out. That duct system on a double wide mobile home triple, they're exempt from us. That's through somebody else. And then it goes, Jeff Ferris said, with the variable speed systems out, a lot of flex duct will sweat when the system slows down really cold air. There are other issues as well. You guys, okay, that's a very good point. Because those blowers do that. That's a good point, Jeff. It does. I've seen that as well. I believe Tom's had some people ask him about that. How do you stop some of that sweating? I just wanted to read them out, Tom.
Good. I'm an R8 man. I believe that R6 was fine 10 years ago, but since we have the inverter systems with super cold air, and as you said, in blower motors that slow down, the air coming off those coils can be 40, 45 degrees. This is based on what everybody tells me across the state. And you get down like that, if you've got even the least little bit of a leak, if you've got the least bit of compression, and you don't have good airflow underneath that mobile home or in the attic, you're running the risk of having condensation and replacing some equipment, replacing some sealants. But hey, that's that's my opinion in your area to work in, isn't it?
Well, that's a solid opinion. Put it like that.
Well, if you're listening in today and you've got any comments or complaints, or you've got code related issues, call in, talk to Tony. Tony is the chief inspector for the state. I always say that when you listen to us, you get the whole horse. You get the horse's mouth, which is Tony, and I'm the other end. So you want to make sure you call in and talk to him, because his opinion is going to be the one that we're all going to live with. There's your phone number. Feel free to do it. I also appreciate the Department of Labor and Licensing and Tony being available. I know this is only 20 minutes or so, and it doesn't sound like much, but it sure takes up a lot of time to put it together and then put it out on YouTube. We appreciate you tuning in, and we'll be back with you again on October the 9th, second Monday of the month, with Tony Woodard, Chief Inspector of the State, and myself, Tom Hunt, with the Arkansas HVACR Association. Tony, thank you, my friend.
Thank you, Tom. Appreciate you.